Yeah, so excited. Just went and picked up that solar water heating equipment that Rod had laid out for me there, and look at this. This is that tank that he was talking about that's all-in-one, you know, electric backup, solar water heating. You know, we'll get some blocks underneath it. We'll get it put in the right way, but just getting it down to the basement's a big effort in itself. So it's great. You know, Rod could come back again and kind of go through how to install this kind of a system. You know, what are the connections? You know, what's the type of mounting brackets that we need for the solar panels and everything else like that. So it's always an exceptional time when you talk renewables. You know, you're doing the eco-friendly house, and everything that keeps with that low carbon footprint is amazing. So it really gets you excited to talk about it. Let's go talk to Rod and see what's going on. Hey Rod, how you doing?
Hi Dave.
Thanks for coming down again. I see you spotted a collector I had laying out here, huh?
Yeah, now that we know that you've chosen to put on 3 4x8 flat plate collectors on the roof, let's talk a little bit about the collector. Okay, this is manufactured by HTP. It is a full plate laser welded product. It has got an aluminum sheet over the top of it that is laser welded onto a copper harp. And so you've got 1-inch ports on the top and the bottom with quick, fast connections on them, so there's not any soldering. So the kit that you've ordered, which we've decided that you're going to do a drain back system with a 115-gallon stainless steel tank that will show you with an electric backup that you've put down in the engine room downstairs.
Right.
And that is a completely solderless system. And will go together very, very easily.
Right. So what's the advantage of that one panel here? Because I know I've seen it before. You can see individual like strips on there.
Other manufacturers, and there's not a lot of manufacturers out there, they'll use the individual strips that are actually attached or adhered somehow to the risers that run up and down. And there's little differences between some of the European manufacturers versus the American manufacturers. Usually the manufacturers use that strip that goes up and down. These are much more appealing looking. Once you see these in the sun, you'll be able to see through the glass, and all you see is a rich maroon blue type of surface that's really quite attractive.
Yeah, I guess it's a little deceiving right now with the light in the windows and the angle that you're looking at.
Yeah, you can't see through it because the mottled glass a little bit there. And I think as technology evolves, we'll start seeing the glasses starting to change, and it'll get more clear as time goes on. But in the sun, it does change compared to what you can see it sitting inside of the building, which is where we'll not spend the rest of its life.
Now, what's the weight of something like this?
This is just under 150 pounds.
Okay, so 2-man can move it around and do what they got to do. Well, that's a good thing.
Yep,
you know,
it is.
About that. What about mounting? What's the suggestion for mounting?
Well, there's a couple different types of mounting capabilities that you have, depending on the type of roof you have. And this may or may not be the one that you use. This is a universal mount, and you've got 4 legs, or feet, excuse me, that clamp on the top and the bottom. And if you want to tilt the panels to a steeper angle than the roof already is, then you'd put a foot right here, or it's a strut, a 1x1 aluminum strut that would go up and connect to the panel.
Okay, gotcha.
So you get
to
a
kind of
tilted
catch the
angle
back side of that. Yeah.
But on your application, on your roof, you've got an angle that's already pretty ideal for the circumstances. So in your application, we'll use just a direct foot roof that will bolt right into the roof.
Okay, does that catch the edge? Or
it does. There's an aluminum groove on the side of it that has a mount that clamps right into it with a little set screw. Okay. It's hard to see, but it clamps on there very strong, and some of the wind tests are up to 160 mile an hour pullout. So anything in the United States would qualify into that application.
Okay, all right, so now that we established, or to say it's drain back, do I have to pitch it? That was the other thing. The wife is always worried about, you know, the appeal. For me, it's the backyard, it really doesn't matter, but do we need to pitch 3 collectors?
The panels you want to give just a minor advantage, but if you think about the plumbing issues that they usually do, the way that they'll plumb for pitch, usually you follow the sewer, which is a 1/4 inch per foot. But also your rain gutters are pitched exactly the same. Right. So a lot of times you can put them at exactly the same angle as your rain gutters, and it will aesthetically fit right into your roof application.
Ah, okay, right. In my case, it's going to be higher here and lower down that end because I want to pitch to the corner to take it away.
Follow the rain gutter.
So that would be the same thing, put the collector slightly pitched, and then it looks like a parallelogram. And,
Correct.
Okay,
Yeah.
right. That was the other thing, we can put them up there and, everybody can do square and plumb and everything else, but, with drain back, I know you want to when the pump shuts
Just
off.
a slight angle. And there too, the difference between a pressurized closed loop glycol system versus a pressurized closed loop drain back system, you need to slope all the plumbing back into the original drain back tank. And if your application that we've talked, we'll look at the drain back tank a little bit earlier, we'll be able to lift the drain back tank and put it up in the attic or close to where the solar panels are so that it won't be a lot to consider. The only sloping you need is between the solar panels back into the drain back tank.
Okay, so it doesn't have to go all the way back down. Just
Correct.
Like back into conditioned space or something like that?
Correct, just in conditioned space. And if you do that, then you can just fill the system full of basic clean water, and glycol is not needed, so you eliminate that service.
Right. Or transfer losses or other stuff like that.
Now, other homes might need to have a drain back tank farther away. It might need to be in the basement, and other arrangements are very, very possible there as well. Sometimes pump considerations have to be calculated a little bit more.
Right. Yeah, my only thing I remember about drain back is it now, even though we call it a closed system, it still requires lift to start the siphon cycle.
Correct.
And so wherever that tank versus the top of the panel determines the lift of the pump. And so,
Correct.
if we could keep it to there, then it minimize lift, minimize horsepower or energy efficiency. So.
Correct. So a drain back system has to consider a little different pump curve, and sometimes because it has to deal with a little bit of a lift versus just circulating the water in circles.
Okay. Looking at jobs, depending on, here in New England, you think about, hey, I got the pump in the basement and the collector up on the roof, and, it's like 2.5 stories tall. You worry about all that pump or lift that you have to do. How do you get around that? 2 smaller pumps or a large pump for the head or 2 in parallel? What's your idea on something like that?
Well, the new pump technology that's coming out is making it quite flexible to where usually for a residential application, only 1 pump is needed. Okay. If you have a really high lift, something that's unusual, you might need a second lift pump. But usually with a good design and a little consideration, a single pump is all that's really needed. And they're not very big pumps as well. They can be quite small. And these pumps are also variable speed because we want to match. When you have solar that's sitting on the roof, the sun is coming around the solar panels, and so your radiation or your heat penetration changes throughout the day. And if you know anything about from an engineer's point of view, you size a pump based on the BTUs or the heat that you're going to move. So as the heat increases or decreases throughout the day, you might also want to speed up or slow down the pump. And that's what we'll do with the control to maximize our efficiency.
So kind of maximize the energy that it's harnessing, BTUs or whatever, will speed up or slow down.
Exactly.
Yeah, the other thing I remember somebody was saying, hey, it's not all about the flow, it's the temperature rise across the collector. Is that basically the term too? By slowing it down, I get a better temperature rise across the collector, or whatever. I'm not producing 80-degree water. I'm producing 120 or 130 usable water.
And that's a good point because you have 2 moving targets. You have the tank that's changing in temperature, it's starting out cold and it's heating back up. And then you've got the solar panel that's coming up early in the morning, or the sun is coming up early in the morning, starting to build up a little bit of temperature on it. So you need to slow that pump down so that it can have enough time for that radiation to build up enough temperature to pass down into the tank, depending on whatever the tank temperature is, which is always a moving target. So you have to have an intellectual control that can see those 2 different things and change the speed of the pump to maximize our
not
performance.
Just a simple on-off differential control. Okay, it's hotter in the collector than the tank. Turn on full speed. Yeah.
No. And TACO did a study some years ago on modulating pump technology on solar, and I think that some of their numbers were 30 to 40% improved performance or collected energy from a solar panel with a variable speed pump control.
Yeah. You were tremendous numbers that you could get with that. But again, just like you were saying, matching the output, that the sun or what you have available. So that's great.
Yes.
That's great. Hey, I put that drain back tank upstairs. You want to go look at that?
Yeah, let's do it.
That's
Let's
a
do
good
it.
location?
Good.
Yeah, so I just brought that tank up here. I didn't know if it required to sit on a stand or kind of sit on the floor or any other recommendations. We get the old spackle pail for everything. So I just have it sitting in this kind of general area over here. But what do I need to think about? Any considerations or?
Just out of the way and in a place that it can be observed once in a while, because it's going to have a sight glass on the side of it here with a tube.
Okay.
And actually the tube will be clear that goes in this application that goes here, to where you can see at a glance if you have any compromise in pressure or the level of the system. But usually that's not it. The control will monitor all that. The initial tube is basically to initiate and to fill the system in the very beginning, which is quite easy to do.
So what's in here?
This is just a stainless steel tank, and this one looks like it's a 15-gallon, which has been sized for your solar array. And it's just a vessel that holds the fluid when it drains back out of the solar panels. So the way that it works in a closed-loop pressurized drain back system is when you fill the system up, you fill it up full of water. The original plumbing contractor will fill it up full of water, so the sight glass is showing the water level in the tank. When the system has a call and turns the pump on because there's heat in the panels, the water will be drained out of this and pumped up through the solar panels, and there's a dip tube in the top of this.
Okay.
So the water will return in the top of this, and now the water level will drop down into the drain back tank, and now it becomes an air isolation chamber.
Okay.
So now you're pumping into a closed loop, and it isolates the air in here.
Okay, so all the air that was in that collector as I pump up goes back down to here and the fluid drops, and so vice versa. When I shut the pump off, that's the air. How does it go? Through the pump or through backwards? How does it get from here?
When it shuts off, it's pumping up through the bottom of the panels, up to the top riser, and out the opposite end and back down through here. When the pump stops, now the fluid will reverse and it drops back down through the panels, goes back down through the heat exchanger, reverses through the pump, and it fills this tank up from the bottom, pushing the air back out of it and going back up to the top, isolating to where there's no water outside when you're under freeze conditions or overheat conditions. So you can't flash the steam or you can't freeze.
Okay.
Very Mother Nature friendly.
Yeah. I like that idea. And, and then the circulating pump is back down at the storage tank location. So plenty of pressure on that pump too, a water column from here.
The only prerequisite is that pump needs to be 3 or 4 feet below the drain back tank. Okay. You can put it in the basement, but it doesn't really matter. Usually the best place for it is wherever it's local to put what the controls are and easy to view. So in this application, probably in the basement, in the mechanical room. Right.
Yeah, I just remember that, you got to have that weight of water or water column on
top of a
circulator to make it work correctly. Yeah, so.
Correct.
All right, well, that's good. So sight glass, we fill it up to a certain level, and then when the pump turns on, boom, the water level drops because it's displaced by the air and vice versa. Oh, that's kind of neat. So the idea is you size this based on the air or the volume of the collectors and the piping and everything else like that. What are we going to do for a piping between here and there? I didn't look in the kit that far to get that thing.
Because this is a solderless system, we use what we call CSST, or flexible stainless steel flex line that's insulated. So one will go one will have a sensor wire in it, which will come off the hot out of the solar panels and come into the top of here, go down into the basement and connect into the heat exchanger on the bottom of the electric water heater that we have down there. And the other one will not have a sensor wire on it, and that will have the pump on it that will come up from the heat exchanger and plug into the bottom of the solar panels.
Oh, okay. Gotcha. Well, that makes it neat. I know it's flexible, it's pre-insulated, and a sensor wire already in it.
Yep. Very simple.
It really takes the work out of that. All right, let's go down to the mechanical room and I'll show you where he put the tank and see if that all makes sense. So we got the tank down here.
Good.
Well, is there any connections that I have to worry about? You said about that recirc port and a few other things.
Well, this is the new SSP tank. So it's stainless steel, and it's got the new stainless steel jacket on the top of it. And the way it's designed is it's got an electrical element that's in the top part of it, and it only heats the top part of the tank. So when it stratifies, so when you don't have enough solar energy, we're only heating the top approximately 60 gallons of water in here to whatever temperature you want to set it at. It's got an adjustable aquastat that's built in here. But our solar coil is right here.
Oh, okay.
And So you're going to put your solar connections down here, and the solar panels are going to come down and bring heat, put in the top of the solar panel, or solar coil here, and it's going to go through and coil down through this coil and heat up the volume of this tank and come back out here. And this is where your pump is most likely going to be on this application. Right. It'll pump back up and pick up heat back in the panels. Now this tank has got the new coil in it. So this has got a stainless steel corrugated 1.25" coil in it.
It looks a good sized coil.
1-inch ports, but it has very, very little head losses. So you can have very, very small pumps. You could also put, this is the same coil that we use for our indirects that you can put boilers on and be that as it may. Now, something we didn't talk about too, for somebody else that has a home that has a boiler in it, this tank can be purchased as a solar tank and have a boiler coil on top of it, so you can you can heat the top of this with as an indirect tank with your coil. Okay. Have with your boiler and have 2 coils in that for a solar input and a boiler input implication up here. So in that case, you'd have 2 ports here for a coil for the solar and 2 ports up here instead of the electric unit. But if you had a gas water heater, then you'd have the gas firing burner that's built right into the tank, which is for HTP boiler technology with a boiler burner type thing that fires right into the tank. That would be most likely one of our Phoenix products.
Okay, so 3 different kind of ways to go around there.
Exactly.
With that direct firing right here, you know, burner built into it, and separate boiler, probably condensing or whatever, but whatever, and then or electric. All 3 different ways of backup.
Absolutely.
But hopefully this is all going to be the primary, right?
This will be the primary heat source, and like I mentioned, we have kits in several different sizes that are solderless kits, so you can go electric backup, boiler backup, or direct gas-fired backup. Be that as it may.
Okay. And cold water always comes in on the bottom on something like this?
Not necessarily.
Universal?
Not necessarily. This is quite universal. The port down here is just simply a drain. All the ports now on this one are on the top. So you have hot and cold in on the top to keep it nice and clean because a lot of applications are coming in from the top. You can use a recirc port if you have a pumped recirc system. You have a recirc port that will give you the capability of teeing into the TMP valve. There's also other products that we have that have completely separate recirc ports that are on the top as well.
Oh, okay. All right. Yeah, because again, the size, the basement and location of things, definitely going to be a recirc, product installed here to keep that water always hot when you open the fixture. So that's great. Any special concerns other than that? Just bring the electric to it. I don't have to worry about flue venting because we're doing all electric. Aquastat, boom.
Yep. The electrical connections are right up here. You can put your conduit right into the top. There's a built-in electrical box right here for your 220 power. You have 2 element types that are available, 4.5 kW or 5.5 kW. That's available in here for a backup. And there's some choices in that realm depending on what your homes or the customer might be looking at this, what their load might be.
Okay, is there an anode rod or
That's a good question. When you're dealing with stainless steel, the properties change and it gets a lot simpler because you don't need to have any sacrificial metals because there's stainless steel is a pure metal that does not need any anode rods. Another thing is you don't want to have any dielectric unions connected to the system at all. So it's just direct connections with copper or a PEX or PVC, what type of plumbing that you're going to use. So none of that has to be serviced. Anything to do to this. You're never going to deal with it.
Of a steel tank, where we're always concerned about that being that low on the list, and you need a sacrificial anode.
And this has no service to be dealt with at all.
That's awesome. Well, that's what we're looking for. Put it in, and the fact is, drain back. We're going to go with probably just pure water, and so we don't have to worry about actually pH changing or glycol's going bad or anything else like that. It seems like it's going to require minimal maintenance.
Very, very minimal maintenance.
Last point on that: is that a specific water I use when I fill a drain back system? Does I've heard about demineralized, this, that, and bottled water or street water. What's your suggestion on that?
The one thing you want to be careful with is I've heard people put distilled water in or deionized water, and that pure water can actually leach out minerals out of some of the metals. So a good, clean water, softened water is all that you really need in the system. Nothing special at all.
No deionized water. Okay.
It's not necessary.
Probably sucking those minerals back in from somewhere to come back in there.
That's correct. Not necessary. Just good, clean, filtered water is just fine.
Well, awesome, awesome. Well, I really appreciate the help here. You know, you give me the diagram, we got the layout, got that package system. That seems to make a lot of sense, that kit. You know, here's all the parts that we need, the tubing, the connections, all that kind of stuff. And, you know, hopefully we'll get that installed real soon.
Good.
And
Look
if
forward
you're
to-
in the area, I'll show you, you know, give you a tour again of it. Or if not, I'll send you some pictures.
Oh, we'll be back. Want to see this all done and running.
Well, there you go. Full invite. Well,
Thanks, Dave.
Rod. Appreciate the great
Alrighty.
information. So, like I said before, Rod is very knowledgeable when it comes to solar water heating, solar thermal here. Like I said, we got all the equipment here. We got the collectors, we got the tank, the drain back, all the ancillary stuff. Now we just got to schlep them up and get them on the roof and get some stuff going here. So, but it's awesome. So, hey, stay tuned. Next episode, we're going to go over what we're doing for siding on the house. You know, it was a big debate. You know, what type of materials to use, man-made, natural, all these other things. We're doing an eco-friendly home, so we wanted to keep around that natural wood. So stay tuned on our next episode and we'll show you the siding that we're using here.